Hi everyone, I'm Julia Hyder, Senior Editor with Modern Machine Shop, and I'm your moderator for today's webinar, which is sponsored by MachineMetrics. In today's webinar, Hamilton Company Director of Manufacturing Phil Linscheid will share how real-time production data has transformed his company's manufacturing operations. Learn how Phil and his team have increased throughput 5 times since 2017 while simultaneously improving production efficiency. Phil will share how his journey over the past few years making strategic decisions to grow the machine shop's impact, as well as how his team uses MachineMetrics to improve production visibility, automate cycle time tracking, increase machine uptime, and enable accurate quoting and planning. We'll cover how Nevada's largest machine shop has improved production visibility, improved quoting, planning, and scheduling with accurate cycle times, and discuss the importance of integrating shop floor data with operational systems. Our presenters are Phil Linscheid, Director of Manufacturing at Hamilton Company, and Henry Foster, Director of Marketing at MachineMetrics. Phil is an experienced manufacturing engineering supervisor with experience in CNC, SolidWorks, TIG and MIG welding, machine tool manufacturing, and lean principles. He joined Hamilton as the Director of Manufacturing in 2018 and was tasked with eliminating the backlog of machining in its Reno plant. Henry is the Director of Marketing at MachineMetrics. He has spent the past 8 years of his career in the industrial IoT space, promoting the adoption of scalable production, monitoring, and analytics for the discrete manufacturing industry. You can submit questions at any time during the presentation using the Q&A tab on the right, and we'll answer as many as we can at the end. And I also wanted to let everyone know that this webinar is being recorded, and attendees will receive a link to the recording via email. So with all of that, let's get the presentation started.
Awesome. Thank you so much, Julia. I appreciate the intro. Was definitely looking forward to this webinar. About a couple of months ago, I had a chance to check out the facility in Reno. Phil and his team gave me a tour there. Just a beautiful, world-class facility, tons of machines, a lot of part operations, incredibly clean shop floor. So Phil runs a tight ship over there, and just excited to dive in today and learn more about his growth story. Phil, maybe you want to say hi real quick?
Hey everyone, Phil Linscheid.
So a couple things we're going to chat about today. First, we'll start off with just a quick introduction to MachineMetrics. Many of you probably already know who we are, but also want to talk about kind of the pervasive problem that exists in the industry, specifically with data and driving visibility and actionability with data. Then I'm going to pass things over to Phil, and he's really going to talk about his journey over the past couple of years. I think he joined in 2017, 2018. Since then, Hamilton has had a ton of growth. And what's really cool about that is that it's not just growth on the shop floor, but true business growth. And on top of that piece, also efficient growth. And hopefully he has some comments there in regards to how MachineMetrics is helping with data on that front. And then we'll finish things out today with some Q&A. So I guess my biggest ask of the audience today is please ask questions. Phil is a wealth of knowledge in this space, and any and all questions in terms of how you're investing in your facility, how you're adopting new practices with technology or processes, how you're making decisions with analytics, please enter those in the chat, and we'll get to those either during it and have kind of a dialogue, or we can get to them at the end, whatever works. But anyways, we'll kick this off here. Quick intro on the MachineMetrics front. So we've been in business for about 10 years now. I've been here for just under 5, and really we kind of got started in the machine monitoring space, figuring out ways that we connect to all your machines in the shop floor, whether that was a brand new CNC that just came off the shelf, or a legacy asset, or even manual equipment like a welder. And we've done a great job in building that platform for connecting all those assets and capturing data in real time. And as a result, we've been able to work with some phenomenal customers across aerospace and defense, medical and device, automotive, basically anyone who's making individual parts and components. So it's been a great journey, and we've really transitioned into driving intelligence from your production, from not only understanding how your machines are performing, but also overall your operational performance. But I also want to talk a little bit today as we intro and provide kind of a foundation for Phil to get into the meat and potatoes of this, of what we're trying to solve for. We see perhaps one of the biggest, if not the biggest issue in manufacturing is that there's a lot of different ongoing systems across the business. And as a result, there's a lot of different data sources, different silos that exist within the business. So whether an operator is trying to capture data off their machine, or whether you're looking at an ERP and you're not seeing accurate production data, or even if you do have some data on production, Well, how is that used to drive maintenance? A lot of these systems are operating in silos, and we're trying to figure out ways that we can capture all this data and drive all those key functions within the business. Now, this is just one of many stats we could call out, but a lot of times we pick out utilization just because it's basic, everyone understands it, and many people are tracking it. The reality is there's this huge rift that seems to exist between what is actually happening on the shop floor and what we think is happening. And it's kind of amazing when we actually integrate MachineMetrics within these machines and production operations, and finally users can see what the actual percentage of utilization and other metrics is. A really good example that we're actually going to be talking about today is cycle times. So utilization may be off here, but what if your cycle times are off? What if your ERP is filled with cycle times that are 5, 10, or 15% off? That's going to be impactful to quoting and costing and planning for the future. Dialing that in is incredibly important, and it's the problem that we're trying to solve here. Now, I think what might be causing this problem, or perhaps what's exacerbating it, is the tools that we use. A lot of them are existing tools that we've always used to get work done, not only on the shop floor, but across our businesses. So just to run through some examples here, I think we can all understand how paper is probably not the best solution, but we're all guilty of using it, right? It's kind of the go-to, it's the Band-Aid approach to capturing data, solving problems, and then we end up entering this data into Excel and other platforms, trying to make sense of it. But there's plenty of other examples for legacy tools here. One even is those basic machine monitoring solutions, which if we're just tracking uptime of machines or part counts, it really doesn't give us the whole picture of the operational performance, all that operational context of what is the status of a work order or what is the cycle time of a given operation. Many times that's missing. And on the flip side, an ERP, although that may be the source of truth, it doesn't really have a way to communicate or drive that change and drive actionability on the shop floor. So it seems like a lot of these legacy tools are really missing out, not only on the data, but how to execute effectively with the data. And really, our goal is to try to figure out a way to capture all that data in an automated way so we can drive those functions in the business, right? We see machine data, as you can imagine, is kind of a foundation of what we're doing. That is the real-time pulse of your business on the shop floor. But on top of that, we need the context. We need to know who was working at that machine, what operation were they running on that machine, what work order is it assigned to. And with that information, we can actually drive operations, we can drive production, we can drive maintenance. And just to get a little bit more specific here, the reality is that there's certain jobs, no matter what your manufacturing business is, that you have to do. There are just certain things that are a non-starter, right? You have to schedule your work. You have to do work order management. You have to understand how much downtime you're incurring and why. And then hopefully you have OEE and you have production analytics. Now with MachineMetrics, the beauty of this is we're capturing the data in real time from your machines, and then we have the context from your operations to understand what work we're actually doing. So this informs a live production schedule. It informs what the status of a given work order is or what our actual capacity is. It also tells us how much downtime we've incurred and why. And the beauty of this is you're setting up a baseline that's based in reality that we can work off of for making better decisions. And Phil has some really good examples that we'll get in today that will encapsulate this. Now, last slide from me, but this is basically just some features on the MachineMetrics platform. I guess what I'd call out here is just that we're built for discrete manufacturing. That is the industry that we were born in, and bred in, we're growing up in, from all the machine connectors that we've built out for this equipment to the dashboards and reports that are out of the box. We're starting with that as a foundation. We're also building the ERP connectors to get the operational information too. And even on top of that, being able to customize and configure the solutions and the reports to your business so you can see the data in the way that you want and that makes sense for whatever operation or function we're talking about is a very key part of the platform. So that's a little bit about MachineMetrics, but I think what will be best is actually talking about specific use cases and how a company like Hamilton is using the solution to drive growth in their business. So with that said, I'm going to pass things off to Phil to talk a little bit about his story.
Hey everyone, Phil Linscheid. Just a real quick, small conversation about me. So I did join in 2018. Prior to that, I worked at Haas Automation for a number of years. I spent many of my years, about half of the time there, of the 11 years there, as a manufacturing engineer, and so and also as a machine shop manager. And during that time, if I ever really wanted to look into optimization or cost or what was going on, we did that with a clipboard at the time. And so I would walk around in the 500,000 square feet of machine shop and assembly areas and walk around and see things for myself, which was great. I really appreciated that one-on-one interaction. But if I needed to see something that was far away, or I needed to see what was happening over time, it was very difficult to capture. So I joined in 2018 as the director of manufacturing in the machine shop here, and we were behind pretty bad. We were not producing enough parts, and we were actually producing so poorly in the machine shop that we were the reason we couldn't sell. And so there's obviously some of you guys on the call here have had situations where people are willing to be patient, but for us, we had a lot of customers that couldn't get what they needed, so they weren't submitting orders, they weren't booking anything with us. And so when I joined, we had I would say between 35 and 45,000 spindle hours of a backlog that we were unable to get ahead of. We had a lot of C-frame verticals that were in play. We still have those machines to some extent, but a big part of what we did to improve that was just understanding what was going on. When I started at Hamilton, there were two buildings that I was responsible for. One of them was Building 3, which is where I'm at currently, and there was another building that was actually a little bit of a walk. You had to walk around this waterway, and you would go to the other machine shop, and it was not possible to see all the machines and what was happening at one time. So one of the first things that we tried to solve really was what's happening, what's going on. Everyone is telling us they're working really hard. Everyone is saying they're doing their best, but are we? Are we utilizing technology? Are we loading the machine before we leave for the day and hitting go and getting that extra part? Are we running during breaks? Are we running during lunches? These kinds of things that typically you need to do, and we were just not doing very well with. So a little bit about Hamilton. Maybe I jumped ahead. I'll share my screen here. So Hamilton is a medical device company. I'm still learning a lot about what Hamilton does as a product. There's a lot of scientists and a lot of chemistry and different things that are part of the business that aren't necessarily part of my job. But generally speaking, most of our revenue is generated from these different machines. And so you think of it like a little 3D printer. Instead of dispensing plastic or having an additive action, these machines are aspirating fluids, doing some kind of mixture, putting them together, heating them up, shaking them, doing whatever they're doing to arrive at some kind of chemistry. And that chemistry then is used for development of pharmaceuticals. It's used for diagnosing. So a company that we deal with pretty often is a company like Quest Diagnostics or LabCorp, depending on where you are in the country. And they have our machines to then handle fluids. And so we have different sizes, as you can see, and the different sizes have more capability, just like a machine tool, more options, more the ability to run more unattended. And that's really kind of where we are in that space. So I haven't seen any questions yet, but if you guys do have questions, I'm hopefully going to be able to answer them in real time. And that would be my preference would be to interact with you as best I can. So if you do have a question, let me know, and I'll do my best to stop that. Stop the slide. So there's some different things here that are seen on the slide that you guys can see. Upper right hand corner here is the earned hours, and I have another report that we can look at that shows a little bit more detail, the part quantities that were produced and the earned hours per machine. So there were a lot of things that we did to resolve our problems, one of which was making sure that we're utilizing the machines that we currently have. Another part of that was buying into and investing into technologies, automation, palletization, bar feeding, things like this that we didn't have, or we did have and we need to exploit further. And so our growth can be explained for a lot of reasons, one of which is we were just doing better based on good data, but also it was an investment in more modern machinery. None of the machines that we had, frankly, were very old, but there was better ways to do it. There were better ways to make good decisions, and making those decisions was really founded on the idea that we needed good data, or we had good data, and they could make a good decision. There was persons that would walk around with a clipboard, and they would track when machines were running, but they would only track when the machine was running when they went by. And so, you know, 1 o'clock or 1:03, someone would walk by and note that, oh, the light is green, or oh, the light is red. And so that only told us when it was at that one instance. It didn't tell us what the trends were. It didn't tell us how the shift was going. And it really didn't also give us anything that we could action on realistically. So in these 3 slides, you can see the growth. You can obviously see there's a bit of a taper in the last few years. Being a medical device, we were heavily involved with COVID. COVID was a very busy time for us. We didn't shut down for a single day, but we were very busy, worked a lot of hours, and ran a lot of parts. And what you're seeing here in the kind of the later years in 2023 and 24 is what I consider to be a normalization. So we are in the process of ramping back up, but most of that is related to just the needs and the demands that we have on the machinery. All right. So one of the reasons we chose MachineMetrics, and from my standpoint, is there are a lot of machine monitoring systems. There are especially even more now than when we made this decision. And one thing we really appreciated from MachineMetrics is their ability to connect to all of the machines that we had, and it really wasn't a question. You can go to different machine manufacturers, the machine tools themselves, and most of them offer a monitoring solution. And they offer that solution for the machines they sell, not all machines that are available. So if it has a FANUC control, you can buy a different connection there. If you have a Haas control, or Siemens, or if you have Mitsubishi, those control connections are available, but they don't really share well, and they don't really want to invest into connecting with the other machines. Now, if they do, they're also limited in what data and what information they can get, what they can gather. So for us, making the decision was relatively simple. We made that decision in 2018, late, I think it might have been early 19, when we really started to take a hold of it. And then every time we would buy a piece of equipment, every time we'd add a piece of equipment or move it, we would add MachineMetrics as part of that capital expenditure, adding just ensuring that we would gain access and gain availability of that data. So it's worked out pretty well for us. In 2022, we went to IMTS, and we actually, a lot had changed. We had COVID. We, came out of COVID, and we went to IMTS with the intention of essentially looking at all the systems we'd already selected, MachineMetrics being one of them, going to all their competitors and seeing if it still made sense. And obviously, in 2024, we still believe that it is the right decision. There were a lot more machine monitoring options in 2022 than there were in 2018, and so we stuck with them, and it made a lot of sense, and we've been still happy. So I just got a question here from Matt Edwards. Can you speak to how you and others developed strategies and sold the project to pursue small factory or Industry 4.0? Was there a roadmap as an example? So it's a good question. So a lot of these things that we did were planned out. There wasn't a lot of documentation. So what happened is I did a massive data extraction from what was our ERP system at the time. I gathered all the data and essentially did some analysis on what our demand was, what our capacity was, based on and assuming that the cycle time was accurate. And so from there, we knew the types of machines. I also broke it up by the type of machine, whether it was a mill or a lathe or a mill turn, and if it was a lathe or a Swiss lathe. And then from there, it was a matter of, it was pretty chaotic. It was very much a short list of things to do. And I had a team of engineers that worked with me and still work with me now. And that team was able to execute based on a very defined and strategic goal. But the goal was very simple. Buy these machines, get these installed, make them running by this date. And so there wasn't a very extensive amount of decision making, or I should say battling. There were so many problems, so many things to do, that doing something was better than doing nothing. And I used to have a boss that would say that you have to do something even if it's wrong. And so we bordered, I think in some cases, I wouldn't say reckless, but I would say definitely that good decisions make sense and you don't have to justify them too extensively. One of the reasons we were able to be successful, very frankly, is the support of the Hamilton ownership. So we knew we had a problem. We knew that I was brought in to solve that problem. As soon as I walked in the door, it was now my problem, and it had always been my problem. And so we knew that whatever we were doing was not good enough. And so we had to get out of that hole. We also knew that even though we had a backlog, even though we wanted to accomplish and get ahead of that backlog, we also wanted to grow. And generally speaking, the company was growing year over year about 20% or so at that time. And we wanted to have an excess amount of capacity available so that we could be ready for anything. And then a few years later, a pandemic occurred, and it made sense. So we're glad we did that. Hopefully I've answered your question, Matt. As far as strategies, there was just a lot of conversation. I went and looked at a lot of different machines. I was familiar with machine tools coming from the builder side of things, and also understanding what our parts were. So one of the things that's pretty hard to share accurately or give you a really good sense. So we make a lot of parts that are about this big, and those parts are machined on 5 sides, if not 6, and we make a lot of different parts. So one thing I haven't mentioned is, so we make a lot of different SKUs or part numbers, item numbers, depending on whatever it is you're talking about. And so as an average right now, we see about 4.7 new part numbers introduced to the machine shop every day. And so even though we are an OEM, we really operate as a job shop. We are a really big, well-funded, well-lit, clean job shop. And so right now, the number of parts that I'm responsible for in the machine shop exceeds 13,000. And so a big part of our success was using the machines, but also figuring out a way to make sure the machines are running. So probably the biggest example of that is going from a machine that's, if it's a lathe, a puck loaded, door opens, machine stops, to bar feeding. And then if it's a mill, you go to palletization. So you go to either a pallet tower, or linear pallet pull, something like that. So hopefully that answers your question. We can get back to it as it makes sense. Will McDonald said, how user-friendly is MachineMetrics interface? How long did it take your operators to learn and adapt to the new system? It's a good question. So there was a lot of pushback initially to monitoring. You can imagine that's equivalent to cameras or people having an idea of being followed or whatever. So there was initially a lot of pushback until the system was in place. Once the system was in place, we could very easily understand what the issues were. And instead of going to the floor after the fact and saying, hey, how come I'm not getting what I need from you, Mr. Operator? Instead, why aren't you doing your job? We can go down and say, hey, I'm noticing a problem here. Is there something that we need to address? And it becomes more of a peer or a conversation or just an interaction as human beings versus you owe me this because this is what I need to be successful. And so I think that's what everyone thought was going to happen, is that everyone's going to be held to some unrealistic accountability. But as you guys probably already know, perception is a very large part of what we are as humans, and we are very often wrong. And so if I look out my window, I can see about 50 machines from here, and I can see that the light is a different color, and I can see the operator. And it could very well be that the light is not green, and I could see the operator, struggling, but I don't know what he's actually dealing with, and I can't see any of that. And so the interface part of it and the data, having that availability and understanding that, hey, we actually struggle with this part, and we've always struggled with this part, regardless of the operator, has really helped us. All right, another question. Thomas, I'm just going to say Thomas D. I'm not sure how to pronounce your last name. Can you please give an example of how your team was able to make a decision based on MachineMetrics data? Absolutely. That's a really good question. So I'm going to jump really deep. It's skipping over some things, but I'll just show you an example. So if I go to this screen, so if you're in the MachineMetrics dashboard or really the terminal here, you can go through and you have a bunch of different tabs on the left. And there's this thing that was introduced and it's called Production Analytics. It's relatively new, but it's probably the most increasingly used thing that we're using right now. So if I click into this, and there's a lot of searching, I'm just going to use what's already loaded on the screen because I'm using some bandwidth here. And easiest decision. So this part number, I can go and click on this part, and I can see, okay, what do I really care about this part? Well, right now I've made 161 good parts. That's great. That's really good. I want to look at the cycles. So right now I can see these are the different cycle times that are occurring, and you can see they're kind of all over the place. You can see 11 minutes, 31 minutes, 11 minutes, 12 minutes. Something's going on there. That's kind of weird. Why is that happening? So the best example of decision. So if I'm not getting, and this maybe is not a good example, let's pick on this one. So this part here, this part is not running well. You can see that I'm running parts goal 51% of what I should be running. We can do better. We should be doing better. But I also can see, okay, well, what kind of alarms are we dealing with? And this actually gives me Pareto analysis of the alarms that are occurring. And I can see that of the cycle of this job running, which has been running for multiple days, 28 hours is going to into this alarm. And then you can see these other alarms. So maybe the operator is doing something wrong and they're setting something to where the machine is not liking that input. Maybe the machine has a problem and it's functionally not working the way it should. Maybe there's something wrong with the program, right? It allows me to go down and kind of understand that really quickly. So we can decide what we need to do very quickly without having to really dive into it too much. I'm doing all of this just to kind of tell you, none of this is, I didn't do there's no work that went into this. We connect to the machines. There's an interaction that occurs that tells us, okay, how do we number our parts? What's in the header of the G code that you have? What things do we care about? What are the things that you use? And we, basically decode that for MachineMetrics, and they say, okay, 93021-01 is a part number. We see that. It's the third line in the header, and that's typically where you guys have it. And they go find that data. So in this, we can go and figure out maybe we have a problem and we need to we need to do something to solve it. We don't actually have to do anything to do that aside from knowing that there's a problem. So I can see the utilization is not where it needs to be, and I can go and hunt it from there. Another thing is I can look at the tooling. So in this example, the tooling, this is a relatively large data pool. I can actually see the tool numbers that are in use, and I can see the average active time per cycle. So a tactical response would be, I've got a problem, I need to go address it. There's some alarms that are occurring. Let's go talk to the operator to see what we can do. Maybe it's a programming thing, maintenance thing, whatever. A strategic decision that I would make is I would go, okay, the average active time per cycle is here. If I sort this, I really want to do an optimization on this part. We're not making enough money on this. We're not making any money on this. I'm going to go and talk to the operator, and then I'm going to talk to the programmer about these parts, these tools, and these tools that are in use for 1 minute 55, 1 minute 22 seconds. Let's see what we can do to bring those down. I'm not going to go talk to the operator or the supervisor or the programmer about tool 25, where that tool is in use for 0.9 seconds. I could optimize that. I could do 90% reduction, but it's not going to help me any. It's not even going to help me a second. I really care about these things here. So hopefully, Thomas, that answers your question. There's a lot of data here. There's really two things that I think I want to impress on the group. There are two interactions that I have very regularly with MachineMetrics, and one of them would be push and pull. So if there's something that occurs, we can have MachineMetrics push communications to me or supervisors or programmers or whoever we decide, and we can say, hey, I have a problem. Great example. No one wants to talk about it, but would be a machine crash. We have a workflow set up. It's very simple, and I can walk through that. I'll walk through that in a second. But we can have a load on a y-axis, and we say, hey, when this load on this axis exceeds this number for this amount of time, send me an email, send me a text message. Go find out what happened. So I have a text message group from MachineMetrics that tells me when crashes occur. So that's a good way of just knowing. I wouldn't know if the machine crashed because it's not visible. I can't see it. It's somewhere else. Another example would be we have notifications set for when machines are not running at full speed. So if a machine is not in full speed rapid motion, it goes to 50%, and it's been there longer, like longer than 15 minutes, it will send me a message, and I can go, hey, to talk to the operator, talk to the supervisor. One of the things that's really great is that you can have escalations. So a great example would be in the feed rate. If it's been a reduced feed rate or reduced rapid for more than 5 minutes, the supervisor gets a text message. If it's been 10, the next person gets a message. If it's been 15, then I get it. So I don't necessarily have to get involved in things that are normal operating procedures. People do need to slow machines down when they're doing prove outs or they're trying to diagnose a problem. We don't want to limit that. We want to make sure that we're helping and we're figuring out what can happen. Sometimes operators would say, I'm running it slower because I don't want to wear this thing out on the machine. There's a feature or there's a function that I don't want to wear out. Well, the reality of it is the machine was designed to go full speed. And we explain that, train them, and we haven't had too many of those issues. So that's a good question. Let's see here. We got a good question. Michael Paul Natier. So can a MachineMetrics help with developing a more efficient shop floor layout? It seems like the data could help with efficiently pairing machines together in a cell that take advantage of the benefits that come with having an operator tend to multiple machines concurrently. So I think if you're smart about it, you can absolutely do that. Probably the best example, and I'll give you a good example here. So we have one work center for a Matsura MAM 7235V, but there's two groups of machines, and they're regional or geographically different. They're one on one side of the shop. We call that, on the left side is called A, and on the B side from where I'm standing is right side is B. There's 10 machines in B, there's 9 machines in A. And I'll share my screen. So if you look at utilization, it's a little bit hard to see on this little screen here, but on the screen I'm looking at, you can see utilization. And this is, I'm looking at shift 1 for these groups. So I look at the whole group as 1, side A and side B. I can very easily see side B is 16% more utilized than side A. And because we're discussing utilization, it doesn't really matter how many machines we have because we're talking about utilization of the machines that exist. So if you're comparing 1 to 100, it really doesn't matter because utilization, it takes it all into consideration. So there is a massive layout difference in the way these were laid out. Side A, they were laid out in a way to fit 9 machines in, and it's not the most ideal. Side B, it's very much a row. There's 2 rows of machines. It's very easy to see. Me personally, I think layout is something to discuss, but in reality, the real reason why I see a difference here is the people. There is a lead assigned to each area, and the lead in side B is just killing it. He's doing very well. You can feel it when you walk in the area. It's cleaner, it's more organized, everyone's on task, they're producing more. And so, yes, I think layouts are part of that. We have had views that we've had in the past and we have not really used much, but you can actually work with MachineMetrics, and there's been options to have an overlay of what the layout is and where percentages are. I don't know that it's very commonly used. I'm not sure if it's still offered, but we did have that for a period of time. And you can see where the layout is and how things are running based on that layout. So for me, I do think that no matter how you slice it, there's always people that are contributing to the success, right? It's the machines and data, but people make a big difference as well. So hopefully that's a good enough answer. Let's see here. Nate Reif. Really like the real-time feedback. Are there common ways a company can use MachineMetrics to improve machine utilization? Can you share some of the typical results? So great example. So going back, and I know I'm jumping around, so I'm apologizing in advance for that. So if we go to the report section of MachineMetrics, I can go to utilization, and I can actually select periods of time and shifts and machines and all of that. And one thing that we look at is, now this is showing a daily view, if I change this to, and let's just say I want to go to this week. If I go to this week and say, okay, I want to look at this week, MachineMetrics is smart, so it says, okay, you probably still want to look at days because you're looking at multiple days, so you probably don't want to look at hours. I can change that, though, if I want, and say, okay, I want to look at hours. And you can very easily see where we have issues. So our utilization in this day is at the 11 o'clock hour, so 11 to 11:59, I'm at 81% utilization. So that's 81% of that 60 minutes. Very shortly after that, you can see that the 12 o'clock hour, which includes lunch, is 69%. But this is a Matsura. It has 32 pallets. There's zero reason why I should see a drop in utilization when the operator goes to lunch. I would argue utilization might actually go up and should go up because the operator doesn't have a chance to interrupt the machine function if it's obviously running in an automated state. So, when we've done these kinds of things and we've talked to operators about it, we have shared the results with the operators, the different leads, and they have staggered lunches, or we've made it very clear, guys, we want you to take a lunch. It's valuable time. If you can work an extra minute or two or leave 5 minutes early for lunch, and it means the machine stays running, do that. Make those right decisions. The way that we rate, there's a quantity portion on reviews, and that's a productivity score, which is the hours you're getting out of a machine compared to the hours you work. And in every area of the shop, we're expecting more hours from the machine than we expect from an employee, meaning all employees have to either run more than one machine during their shift, or the machine has to run when they're not here. Well, that could be lunch, or that could be when they leave for the day. So I'm not sure if that answers your question, Nate, but there's a lot there. Matt Edwards, can you speak to what real-time dashboard or insights that a worker is leveraging? So yeah, absolutely. So there's two examples. So this is a dashboard. This is called the current shift dashboard. And we have these, this is a screen on my screen. I actually have a monitor in my office, and there's monitors throughout the shop that are tailored to the machines in a particular area. Every one of those areas has a lead. And because the machine shop is somewhat big, I mean, there's obviously bigger shops, but we have a lot of tall machines, so you can't see the status of every machine in all places. In the Swiss area, the machines are really short. It's very simple. And we have a lot of tall people in that area. But in the milling area, you can only really see one machine when you're at one machine. And so we put these dashboards that are in the area. Now, what we've done, and this is kind of a nuance, and there's arguments against it, but we actually are running 3 different shifts for one shift. And the reason we did that is so if I look at utilization percentage, which is a very easy thing to understand, like Henry mentioned, and it's a very infallible metric. How much time did you use it versus how much time was there? I always think of utilization as 24 hours, 7 days a week, so 168 hours. So my targets have always ever been 60% utilized, which really means 100 hours in a 168-hour week. And the reason I do that is because when I'm communicating, I'm always communicating in the real number. I'm not doing, okay, we expect people to be running 80%, so 80% is now 100, and now I'm 80% of that, right? Which is kind of, we walk ourselves into being really, or justifying really inefficient behaviors. So this is a dashboard. We have these in the different areas. There's one per main area, and one lead is responsible for those group of machines. So this is something that we use to help identify, hey, these have been off and been off for a period. So you can see 316 here has been out of cycle and been idle for 4 minutes and counting. Once it goes over 5, it turns red. We can change all of that. So 5 minutes for us made sense, but it looks like they got to it before it changed. This is a bigger dashboard, but then on top of that, if I wanted to, I can go to, let's say I want to go to machine 214. So this is a dashboard that is visible on a tablet. So every machine that we have that's connected to MachineMetrics, all of them are CNC, all of them have a tablet, all of them are displaying this screen here. And because they're tablets, they're touch screens, but for me, I'm clicking on a mouse. I can see, okay, here's what our utilization looks like. Here's what our current cycles are, our part counts. And so right now you can see what my last cycle times have been, what my average has been, and you can see what's going on kind of as you go throughout time. Utilization, you can see hour by hour by hour, and this is not a planted example. This is 100% utilization, but that's really what happened. So they've made 8 parts since then. This is available to all employees on all tablets, and so this will tell them kind of what's happening. Also on here, there's another functionality which we really do enjoy, and that is this workflow. So if I were on the tablet, I'd be touching it with my finger. I click on the 3 lines, I click workflows, and I can say, hey, this cycle time is not right, or I need help, supervisor, or the machine is disconnected, please contact manufacturing engineering. There's something wrong. If they click these buttons, and I'm just going to click it here, hopefully the supervisor doesn't come see me, but if I click here, it actually sends that supervisor a text message with the machine number and the part number that's running and the date and everything else. And so it's a way of communicating when there's an issue without having to go find somebody. We run a really lean leadership team, so we have supervisors and leads that we rely on. We have a lot of leads, but they're small groups. So a lead will have maybe 5 or 6 people that they're responsible for, and then probably double that in terms of machines. But then supervisors have 4, 5, 6 leads. And so the supervisors are very mobile, and they're very hard to find. Well, their phone is always on them, and so we don't have to worry about that. Yeah, hopefully that answers your question, Matt. Do they know they're winning? Yeah, so do they know they're winning? Absolutely. So the idea is that you can see the utilization by the different shifts they're in, or you can see that this one here is a good example because you see the system doesn't know what it's expecting in terms of parts, and that's because we're still implementing a few things on our end, mostly because we have a lot of parts. It could very well be that the data in our ERP system hasn't caught up. So they will actually, on this one here, you'll actually see, let me show you another one. Let's go here and see if this will get us what we want. So you can see right here, so you have where you have made 1 part, you expected to make 3, here's where you are, here's where you need to be. So you're behind, and it'll tell the operator they're behind and kind of express some urgency there. So the monitor that you have on the wall is showing whether it's being utilized or not, and then the tablet can show whether you're on target or not, and depending. And because we have operators that are somewhat I would say they're in a zone offense or zone defense, I guess, and so they're moving and they're going from one area to another area, and when they do that, they need to be able to see what's going on very quickly, and they look at the tablet. So yeah, good question. Chris Schooler, the data pretty much aired all the dirty laundry. The data didn't implement or drive the 5x improvements. When you parodied the potential changes, what were the big ones? So yeah, it's good data, right? Henry mentioned that. Everyone knows that. If you have bad, garbage in, garbage out. So what happened is, and just to kind of give it some more context, we made a lot of purchases when I joined, but we actually bought a lot of machines prior to me joining. And what happened is they bought a lot of machines and saw almost no improvement. They saw no additional growth. They saw no additional output. The hole they were digging kept getting deeper. There was no improvement. And so because they didn't have a good way of measuring it. And so then after that, there was all this panic. And so people were walking around with clipboards and taking a snapshot of what the machine was doing for that 5 seconds when they were there, not the 168 hours in the week. So yeah, Chris, that's a good observation. Second part of that question, what were the big ones? So the big ones, obviously, is just utilization. That was the main thing we looked at for years, is are we utilizing it or not? Another big part of it, which we haven't discussed and we haven't gone over, is because I had the connection to the machine and because I was able to get a lot of information from the machine, I was able to see what spindle speeds were running. I was able to see what feed rates were being commanded. When we first bought our first 20,000 RPM spindle machine, every program, when I did an audit, every program tapped out at 15,000. And so I made a screen capture of that, went over the program and said, hey, what are we doing? Why aren't we using the machine to its capacity? So very quickly, I was able to find that there were problems. What are the big changes? Process changes and or significant CapEx. So a lot of capital expenditures we did buy, but ultimately, like I said, there was a lot of that prior as well. I think there were about 15 Swiss lathes that were purchased before I started, and we saw almost no improvement. You can kind of see that here, actually. So this is a kind of a messy look, but this is a less pretty version of the one that Henry had created. So you can see the output here. So I joined right around here, and then we started to go up. Now, we bought a lot of machines during this time, and you can see almost no discernible improvement week over week. You see a little bit here, but for the amount of machines that we were purchased, we weren't seeing much of it. There were, like I said, 15 lathes, Swiss lathes that were produced or were purchased. And if I go just looking at Swiss lathe, you don't really see a big improvement here. You don't really see much of anything. And these are weekly goals. These are weekly hours that were being achieved. And so, you should be getting 10 to 20 hours, let's just say on a good week, you get 80 hours a week per machine. When you buy 15 machines, you should be making hundreds more hours, and you're not making hundreds more hours. You're making 100 more. And that's only because you just are running the machine slightly more, if that makes sense. So, good question. Joshua, sorry for the last name, Rafenez. Are you implementing MachineMetrics with your ERP system currently? We are not using the ERP system directly with MachineMetrics. We are linking them, and we're also in the process of making that connection. So the best thing I can show you is we have a lot of Power BI reports. We use a lot of Power BI reports on our end. We have Dynamics 365. Dynamics has a lot of data. MachineMetrics has a lot of data, and what we're doing is we're piping those data channels or data chains or blocks or what data cubes, whatever you want to call them, data lakes, into Power BI so that we can do some analytics. And so we have some reports that will show us what the variance is. So variance for us is the difference in what you're doing versus what you were expected to do. And so we have a cycle time that say, and I'll pull this up. It may take a second to load just because what's going on here. But if we go, let's see here. So we go to the variance report. This is a report that we built, and it's using both MachineMetrics data and Dynamics data. We are in the process right now of making the variance report automatic, or at least having a workflow where a human being approves it. But the idea is that we eventually get away from human error, and we get away from data errors. And because we have so much variability in what we do, we have to have that. We have to have that portion of it. So looking at machine shop variance here, you can see this is the milling, this is the lathe area. Blue is Dynamics, green is Dynamics, green is MachineMetrics. And so you can see that in terms of hours, in terms of minutes, and then the variance themselves. And we are looking at these things and making changes. So this is a report that runs, it updates every morning about 6:30, and then it doesn't update again until 6:30 the next day. So right now, every morning there's a manufacturing engineer or a programmer or a supervisor that will get this notification, and they look into it and make the changes based on our system. So unfortunately, we just have to assume that the things were fixed on my end, or I have to go confirm with the engineer to know that the next day, tomorrow, these ones will not show up. We've got some significant differences here. You have MachineMetrics says it takes 19 minutes to make that part. Dynamics says 42. There's a big difference. And we are going to need to fix that. And we need to fix it quick so we can gain those hours. Everything in the shop is very simple. You have the cost that you're operating at or what you're spending, and then the amount of hours you can produce, and that's your cost per hour. And so if if I'm adding 22 hours when I shouldn't be, that's a problem. If I'm missing 14, that's a problem. Neither one of them is good. Sorry, I'm reading the question here. Chris Schooler, is the platform better suited for standalone machines / high mix, low volume type business models, or can it also benefit from serial automotive type production lines? I actually think that MachineMetrics does both well. You're going to use different aspects of MachineMetrics depending on what you're doing. So one of the reasons that I use utilization is because we're running a different part all the time. In fact, right now I have over 800 different production orders that are in some kind of state of operation. And so I can't necessarily say my takt time or my throughput today should be 8 or 100 or 4,000 because tomorrow it'll be different. And so I always kind of default back to utilization. Utilization allows me to see is the machine running. And then I can look at my variance to see, okay, is the time right? Is it not right? There are examples of parts where we have 1 or 2 parts dedicated to a machine. It's a really complicated part or requires a specific machine. And we move away from utilization and we move to throughput. And we do that with MachineMetrics data as well. But it depends on kind of what we're seeing. Generally speaking, I think we're a pretty high mix. But we do have examples of where both make sense. And I do think that MachineMetrics does well with both. From a manufacturing engineering standpoint, it's kind of an agonizing state of being right now because there's so many things going on and I want to fix them all. But the reality of it is I can't. So I have to figure out, okay, which ones are the highest impact? Which ones are going to be the ones that give me the most gains? If I was doing low mix, high volume, more like automotive style, I actually might gain better because, let me show you what I mean. So here we go. If we go back to the summary, let's go here. Actually, I just want to go, let's go back here. So if I go here, so here's a great view. So I'm looking at machine 1 or 1042. So in your question, Chris, 1042 is a Swiss lathe. It's a L220. And I can see what's happening. And I can see how it compared to yesterday. And this is just automatically how it looks. You can change views, and there's a way of doing it. For me, I don't really look at hour by hour, but you can very easily see today is not going well, right? Today is not as good as it was yesterday when comparing yesterday. And so there's a baseline is a terminology that's used very often in MachineMetrics. And in the baseline, they show here's how it runs normally, here's how it was running yesterday, here's what it's been doing, and all the different examples. So let me show you maybe a better example or maybe a different example. So I'm just going to search a part. And I'm going to click here, and I want to go here. So let's go through a couple of views here. So here's a good view. It's very just data. There's not a lot of pictures here. But I can see, okay, this part has run accurately, or sorry, has run on 13 different machines. It's had 16 different runs since 2022. I've made 66,000 parts. This is maybe a good example for you. I can see my different run times, but it also breaks it down and says, well, here's what we got every time you ran it on this machine. On machine 103, you ran it once. On machine 208, you ran it twice. And you can see and compare, look, you can see, hey, these cycle times are not the same. They're off by a few seconds. But when you're making 60-something thousand parts, a second is a lot. It adds up quickly. And so this is something that I would use heavily if I was doing something that was more automotive style, where you're making just a ton of the same thing, or family type parts, or parts that are familyized, or whatever you want to say.
We have another customer that, like, right now they kind of have a run to failure strategy, right? They're in automotive, so low mix, high volume, and they just run it till it fails. But kind of on both sides of that is a problem. One, if you stop it early and do maintenance or fix an issue, downtime, or you wait and then you have the failure and then you have scrap parts after. So what we're doing for them is identifying when it's going to fail. So only stop it and initiate the maintenance. Then you're not having the downtime and you're also not having the scrap parts after. That's pretty valuable on their side too.
Yeah. Another question, is it okay if I keep going with questions? Hopefully this is worth your guys' time. Obviously I can not talk about it, I guess, but Thomas, you do have a question, and I think it's a pretty good one. It says, thank you. With 30,000 plus parts, to what extent are you analyzing individual jobs versus individual machines versus overall production performance? So, excuse me, the answer I give you is it depends. Even though there are thousands of parts that I'm responsible for, there are several of them that I just know. You saw I typed in a number. That's a number I'm familiar with, right? It's a number we make a lot of. It's very critical to our business. I think this fiscal year I'll probably make 500,000 of these parts, make a ton of them. So this, because we make so many of them, is very price sensitive, right? And this is a new version of something we used to make. And so from a sales strategy, we are offering a lot of this at a really pretty low competitive price. So this particular one, I will look at all of this data, right? I'll look at, okay, why is this machine running slower? Why is this machine running higher? I'll also be able to look at these parts and determine who ran them. So it could be that there's a person that's running better. Now, one thing that we're not talking about here is none of this tells me whether or not the parts are good. We do not use MachineMetrics for scrap capturing. We use our ERP system, and the reason we do it is because I firmly believe the human beings in the shop are here for a reason. There are certain things they should be doing, and I want to have them focus on making good parts. If they're focused on data entry, if they're focused on clocking to a job to make sure that I can charge the right thing, it's taking away from the thing that they're good at, right? And so for me, what we do to understand what yield and scrap is we say, okay, we're going to issue this material. We have a pick list. It's on the bill of material. We're going to issue 1,000 inches or 1,000 bars or 1,000 pieces. And at the end, you're going to give me a resulted good product that's been inspected and validated. If let's just say simple numbers, I give you 100 pieces of material, you give me 98, my scrap is 2%, my yield is 98. And there's no way around that. There's no arguing, because the quantity that goes to stock is then confirmed by the people that are in the warehouse. So there's no additional work from my guys either. They don't have to necessarily tell me what they scrap. They can just tell me what's good and what they're signing off on. And so so I'm doing both. Problems resurfacing, that's a big one. So it's not within the MachineMetrics space, but it is something that we do. We have this thing called manufacturing quality alerts, and anytime we have a quality issue, we add it to the electronic work instructions, and we train everyone, and we make sure that they see that and they don't see it again. And then we record kind of the history, the chronicle of what had happened. So hopefully that answers your question.
All right, I'm going to put out a last call for questions. We have a couple minutes left here, but if we've covered everything, we can go ahead and wrap it up because we are almost at 3 o'clock. Okay, it looks like we're not getting anything else in. So, oh, wait, one more question. How long did it take to have MachineMetrics in place and fully functional for 87 machines?
You know, Sally, this is a really common question, and it's unfortunately a very unromantic answer. Really did not take very long. We were when we were installing machines, we literally installed 6 Swiss machines in a week, or 8, or whatever when we were buying them, and the connection was very simple. We'd plug it in, we'd identify the machine on the network with its particular IP address. There might be some setting on the control, depending on the make, for us to turn something on.
Okay, I'm seeing that Phil is frozen. Henry, are you also having problems?
No, I think I'm still on here.
Okay, but well, is Phil frozen for you?
Yes, he is.
Okay,
but at least
all
we're
right
here. So, Molly, we're happy to get in touch with you and talk deeper about the implementation process. I can actually connect you with Phil if that's helpful.
Awesome. I think that's a good place to wrap it up for today. I want to thank Phil, Henry, and MachineMetrics for making this webinar possible. And thank you to everybody for listening in. You should receive an email with a link to this recording soon. Thank you for your time and enjoy the rest of your day.